Thanks Amit for the introduction and good afternoon everyone. Oh, it's a full house. Okay. Makes you nervous when you stand in front of a full house actually. So first of all, thanks to MLDA's team for giving us the opportunity to present our work here. And actually thanks, kudos to all of you after the lunch to come and join the session. I'll try my best to keep you guys awake as much as possible, and let's see how good I am at that. Okay, so I think just quick one more thing. I would like to also tell that my team member Varsha and another team member Abhilash, who is in the audience, they are the core team members who helped us on this and implementing this OCR work. So I think everywhere it's about the AI agents and also about the RAGs and all. But I think a lot of this depends on the OCR as well, right? So making use of OCR becomes important for us when we want to do any of these AI agents, RAGs and all that for extraction. And I'm sure all of you all here know about OCR, but just for the general audience also, right? So OCR is optical character recognition, and it helps us in extracting text from the documents, images, and PDF kind of files and all, right? So it helps you extract the text, and it is useful. Once you have that information, you can store it and you can use it for the further downstream tasks. Okay, now coming to why did we even get into this, right? So we had a situation where we had to work on extracting the text from almost 4 million documents. So that was the situation where we had, and we realized that cost is something very important over here for us. And that is where we decided that I think we should spend some time to see if we can implement something in-house to help us reduce the cost and manage it. Because end of the day, cost is a very critical factor for any project. So taking care of that is very important. Second thing is always the third party part, right? Always gives you that privacy concern, right? Whether they are using mine for something else or not. And then comes the customization. So mainly if something that you have built, there's a good chance that you can try to customize it for using it in any other aspects. So the current process that we have is simple, straightforward. Take the document or take the PDF or image, send it to the third party and extract the text and tables. This is how the current process is. But when we decided to go and try to approach this with the in-house OCR capability, so we wanted to create some data sets to test our modules that we are working on, right? So for that, what we did is we created 3 types of documents. One is like the digital document, another one is the noisy document, and the third one is the handwritten. So the digital documents we created with SynthTiger. It's a way to generate documents with different font size, font types, layouts. You can add distortions, everything you can do for that. And then these other 2 are open source data sets. The digital noisy documents are, there's kind of a noisiness in the text that is there. So we took the FunSD data set, and handwritten we have taken the IAM data set. And when we started doing our research for this, right, so we realized there are a lot of options available, and we didn't have enough time to go and search for everything and test it out. So we tried to narrow it down with an evaluation criteria. So what we looked at was looking at the activity, like how many GitHub stars are there, what was the latest release, then how much of activity is there in that repo. So we took a look at that. And then capabilities. So seeing what languages it supports, then kind of what are the compatibility with other tools, right? Those kind of things we checked. And then finally the usability part. Although there are things which you can directly use, but we always want to have a choice of training it if required. So that was one other option we were looking at when we were looking at the frameworks. And you can see some names that we have looked at. So MMOCR, Keras OCR, GOCR. But I think we narrowed it down to these 4, which is Paddle, Tesseract, EasyOCR, and HDR pipeline. And these modules, right? So when you look at OCR, there are 2 parts in it majorly, right? One is the detection part and then the recognition part. So there are several options available in both of them. So there are a few names you see, right? DB and East. Then you have the word detector NN. So these are different modules we tried, and we found it works out. These combinations work out well for us. And there is a mention of another module called DocTR, which also looks promising for us. We are planning to take it further and do the checks on how it performs for our documents. Okay, so coming to the kind of process that we have now, right? I mean, the one we have tried to implement. See, we realized that each of these modules, right, or frameworks have their own strengths and weaknesses. So when we started looking at the results, so when you get an output from OCR, what are the things that you get is, one is the bounding box. Bounding box meaning telling where the text is present in the document. And second thing is you get a confidence score, which tells how confident the framework is in the text that has been extracted. So we picked up the documents which were having very low values in the confidence score and seeing them, what is the issue that is there in that. So we noticed that, for example, paddle, right, tends to fail when there is dense text. Okay, lot of paragraphs with lot of text, right, it tends to miss the words. Whereas tesseract, whereas it works well on tables. If there's a table structure, you can extract the text from the tables. And then you have the tesseract OCR, which works well on dense text also, but then kind of on tables and all, it doesn't do such great work over there. So what we did is we combined both of them to see if it helps us improve the results. So what we did is we took both the outputs and saw which one has the highest confidence score and pick up that one. And then second thing is we also saw if paddle has found the output and tesseract didn't find, we picked up that value for us as the output for us, and vice versa as well. Okay, so I think this part I'll be a little quick. So evaluation metrics, just to make sure how the results are coming out for us. We looked at these three: word error rate, character error rate, word error rate, and accuracy. So this is at the character level. We are seeing how many mistakes are happening. Lower the value, better for us. Word error rate at the word level, how many errors are happening. So that's also another metric. Again, lower the value, better for us. Accuracy is actually again telling how good is the model with respect to the text that has been extracted in terms of words. Higher the value, better for us. Okay. So this part, right, I think this is the kind of results we got. And actually when I got these results and I was reviewing with the team, the first thing that thought came in my mind was looking at the open source OCR, right? Like I could sympathize with these open source frameworks. It was like, my aging eyes, it cannot differentiate between a 0 and an O, B and an 8, right? Those kind of issues. But whereas the third party APIs, they do a very good job in getting those, small things. So if you look at the results, naturally the third party APIs are excellent. They have almost 98% for digital, noisy also almost 99, and on handwritten it is around 97. But if you notice, the digital documents with paddle and tesseract and EasyOCR, they also seem to be doing good job over there. And when we combine them, so we made a hybrid one, which combines the paddle and the tesseract. So there was marginal improvement. At the same time, the error rates have come down a little bit. And same thing with the noisy document also. We had slight improvements and the error rates have come down. There is definitely scope for improving the results. This is more of a journey for us and a lot of learnings for us, and we are trying to be now further experiment with ways to improve the results. I think we are pretty close. If we could reach somewhere around 96, 97, I think it is a good thing for us. So that's where we have these results, and this is for handwritten. Clearly paddle, tesseract, EasyOCR don't seem to do a good job on the handwritten, but HDR pipeline did a very good job on that. So you can see that 85%. Again, handwritten sometimes, even I look at my handwriting, I don't understand sometimes what I have written. So I think it's a tough job over there. So it's 85% is a pretty decent work. Okay, so this part is majorly of how to make it easy for our business to understand and accept, right, of how good our results are. So as a first thing, right, as soon as a business comes to us with a use case, what we do is we immediately take their document, and this is hardly, let's say, an hour's job we just generate, I'm sorry if it's not so clearly visible, but we generate an output like this, where on the left side you have the original document, and I mean the original page, and the right side is the extracted text in the same positions of where it has been seen. And we also generate an Excel output or a CSV output with the table extractions and also the raw text. This is like an immediate output that we generate and give it to the business to check how good we are able to extract the values. So this is one quick output that we generate. Okay, so as a person who has to design the solution, for me it's very important that not only implementing the solution but also making sure that the cost is taken care is very important for me, because end of the day, if we are not able to deploy it, or even if we deploy it and the cost become high, it's very challenging to keep it running. So that is the reason why we decided that we'll not have a front end kind of a UI for this, because when we go for a front end, we have lot of infrastructure cost, implementation cost, resource cost, right? So we don't have that. We did a backend API which is deployed on Kubernetes. So you can pick the files from anywhere, and then you have the Kubernetes running the API, it gets executed, and then you dump the output. And further, to improvise the cost also, what we did is, we have 3 different types of architectures. One is for an event based, one is streaming, and one is batch. So based on the use case, we try to deploy the API for that scenario. We don't want the API up and running whole day, right? It's unnecessary cost. When there is a requirement where only weekly once we want to execute, we have a batch process. When there is really a requirement for streaming, we go for a streaming. And sometimes it's like, a file comes in, then only we want to trigger it, we have the event based. So this is how we have designed it to manage the cost part. Okay, I think this is a lot of things. So what we have also done is now, we have created templates. These templates, right, have made our life very easy. The turnaround time has become very quick, and there is no dev work involved in building the extractions that happen. So these 6 templates, right, what you can do is, we have tested it and it has worked in different scenarios. We have exposure to a lot of use cases with different scenarios. So these templates could handle everything. So what do these templates do is, they basically, you have a specific table to be extracted or specific paragraph to be extracted, you can just define it in the template and it can work on any document. So that's how we have different features, like you have hook based, where you can define a hook and below that whatever is there it will extract it. Then you want to extract a particular row, you can extract that. Or there is a kind of a spatial relationship also, right? You can extract those kind of values also. Yeah, I think these are all the different features that we have. Okay, so I'll hand it over to my team member Varsha, and one important thing is how this OCR is also helping us is, there is something called as table extractions and barcode also. So we have a lot of labels from which we need to extract the information, and that is where actually this kind of frameworks also help us in the extraction.
Thank you, Karthik. Can you guys hear me? Hi all, this is Varsha. So we experimented a few frameworks, models for table extraction. In that we took table transformer from Microsoft, which gave us better results actually. So in this, in the behind they are using detection transformer model for detecting tables in a document. So they have used 2 detection transformer models, but they are trained on the 1 million data set, but with the different object classes. So one they are using for table detection. So when we get an input, it will try to be using the detection transform model. It has been trained on 2 object classes, that is table and rotated table. So it will try to detect the table. Then in the next step, using the same detection transform model, but here it has been trained on 6 object classes. That is like it will try to detect rows, columns, text cells, and also column headers and row headers. So at the end we will be getting the, in a document, it will try to detect the table and its components like rows, columns, and its column header and text, row header. So this is the currently we are using this framework for table extraction. So when we get an input, we'll try to use a table transformer for detecting the table in the image. Then using this, so we also get the cells and rows and columns. On top of it, we are using paddle OCR to extract the text from each of these cells. So at the end, we will be having a result. It is a combination of like table detected by Microsoft table transformer and text detected by extracted by paddle OCR. So with OCR, we also have barcode decoder in our flow. So as we all know, barcode is nothing but it is the like visual representation of data. It will be in machine readable form. So there are two types of barcode. One is linear and other one is matrix. Linear is 1D. It is it has a series of lines, and the other one is like it is a 2D. So example for these are linear is it can be a vehicle identification number or product. In the matrix, it is nothing but the QR code and data matrix. So this is the flow we are using to decode a barcode. So when we get a document, we try to convert this document into image, and we use a method called as clay actually. It is a method used to improve the contrast of the image using a histogram equalization. So it helps to reduce the noise in the image. Once this enhanced image, we are sending it to YOLO V5. So this YOLO V5, it is trained on to detect the barcodes in the image. So if YOLO V5 fails, we are sending the entire image to barcode decoder. So here in barcode decoder steps, we are using three packages actually. First one is Z6CPP. If that fails, we are using Pilot TMTX. If both of these open source models fails, then we are going for a third party. Suppose if YOLO V5 finds out the barcode in the image, we are cropping that image and we are sending it to barcode decoder. So wherever we have barcode decoder, we are using the same three packages to decode it. Suppose it also fails in this step, we are trying to enhance the image using a super resolution model called EDSR, that is Enhanced Deep Residual Network for single image resolution. So it is trained to improve the resolution of the image. So at the end, we'll be getting a high resolution barcode image, crop barcode image. This we are sending it to barcode decoder for further decoding. So this we tried it on 165 files and we got an accuracy around 84%. Okay. In this journey, we also experimented multiple techniques that we can use to enhance the OCR results. So first one is like how we can use AI as a post-processor OCR error correction. So in this, we are taking the text from the open source model, and the text which has very less confidence, less than 93%, we are taking that word with the preceding and following 5 words, and we are giving this code like context snippet to the ChatGPT to enhance to correct the low confidence word. So by this way, it will try to, it has given us like 3% of, it increased the 3% of accuracy. Then we also tried LLMs and VLMs for OCR tasks. So like Llama OCR, QN models for OCR tasks, and also GeoD OCR 2.0. In this case, it accepts bounding boxes and image to give the text. But the limitation we found in these things are it doesn't provide us bounding boxes. It requires extensive resources, and there is also limitation of output tokens it generates. Next is OCR free RAG. So there is a model called Kolbali which takes input and it gives us it identifies the text in it and answers it directly from the image. So by this, it tries to bypass the traditional OCR. So in turn, it uses a VLM to extract the text, but as those VLMs have contextual understanding, and it understands the relationship between the visual elements and the text. So this performs very well when compared to our traditional OCR process. conclusion, like we have multiple open source models. They have their own advantages and disadvantages. But when we combine them, it gives us a overall better accuracy. And we can use VLMs if we don't need a bounding boxes. These also provide us better accuracy based on, because they are trained on contextual understanding. So yeah, that's it. Thank you.